Okay, for this question, the ages of a sample of 40 students were recorded. The results are given in the table. Now we need to use a scale of 1 centimeter to represent 1 year on the horizontal axis for 8 to 19, and then a scale of 1 centimeter for 1 unit on the vertical axis for the frequency densities, and also on our axis we need to draw a histogram to illustrate the distribution of these ages. First of all, to be able to draw a histogram, we need to find the frequency densities, and this is what I've calculated here. And the best way to do this is to take the frequency divided by the class width. For example, 3.5 is going to be equal to 7 divided by 10 minus 8 is 2. This one's going to be 8 divided by 11 minus 10 is 1, 6 divided by 12 minus 1 is 1, 10 divided by 14 minus 12 is 2. So as you can see, this is just using the formula here. And of course, 8 over 1 is 8, 6 over 1 is 6, 10 over 2 is 5, 3 over 2 is 1.5, and so on. And the histogram is looking like this. After we've drawn it, here we go. That's what we come up with. Frequency densities and the intervals. Alright, so this would be your answer in the exams. And of course now we need to move on to the other part. In which interval does the median lie? Now for this we need to calculate the frequency densities and then look at the middle term. The middle term is 40 students here. Well, you can divide that by 2, get the middle term. 40 divided by 2 is 20th, so that's our middle term. This is where we're going to read the median. So if you calculate the cumulative frequency, you got 7 plus 8 is 15, 15 plus 6 is 21, and so on. But we need to stop at 21. Why? Because 20th is covered by 21. So the median is going to be here. So the answer to the question is then 11 to 12. So you can write it as such. Or you can just say 11 less or equal to x and less or equal to 12. It's the same thing. Alright? Now for the next part of the question, we need to calculate an estimate of the mean age of the students, and part D, calculate an estimate of the number of students who were under 13 years old. Now, an estimate for the mean, we're going to take the midpoint of each of these class intervals, and then we're going to multiply by the frequency, and we're going to calculate the total. So this is what we've come up with by taking the midpoint. Here we go, 9, 10.5, 11.5, 13, 15, and so on. And then we take x and we multiply these out, we get these values, these totals. And from here we can find the mean. So the mean, an estimate of the mean, is going to equal to 496 divided by, which is fx over f, over 40. So 496 divided by 40. That's going to give us 12.4. So estimated mean is now 12.4. Students who were 13 years old or less. An estimate of the number of students who were 13 years old. Under 13 years old. So under 13 we're looking at, if you look at the diagram, 13 is here. So and from here to here we've got no problem. These values have been given in the question. For this one is 7, this one here is 8, this is 6. Now but for this one here we've got 10. So you've got 10, so you got 5 here, 5 here, because divide by 2 you get 13. Alright? So that's how you look at the areas basically. So the answer to the question is then 7 plus 8 plus 6 plus 5, 26. So we can say that this one is 26. So that's the answer. And then also for the part E of the question, one student is chosen at random from this sample of 40 students. Write down the probability that the student is under 8. Those who are under 8, okay, so you've got 8 and under 8. So how many students are under 8 years of age? Here we go. We're starting from 8 to 10, alright? So we don't have any students under 8. So basically the probability is 0. And then over 16. And over 16 is here. Greater or equal to 16. So over 16 we've got 6 of them. Alright, so that's going to be then P that x is greater than 16. Okay, is going to be equal to, we got 6 of them, so 6 over 40, that's going to make it 3 over 20. Now for the last part of the question, a second student is now chosen at random from the remaining 39 students. Calculate the probability that one student is over 16 and the other is not over 16. Now if the student is over 16, what it means is that its probability that he's going to be over 16 is 6 over 40, because there's 6 over 15 here, so 6 probability that x is greater than 16 is going to be 6 over 40. The probability that it's not going to be 16, that is x is less than 16 then, because the other one is not, is going to be 40 minus 6, which is 34, divided by 39, because one is already taken. So these two, they can happen, they are independent events. Or the other way round, meaning that you could pick the first one being less than 16, therefore that's going to be then 34 over 40 times the second one being greater than 14, then 6 over 39. So we have a combination of two probabilities. The first one we got was 6 over 40 times 34 over 39. If you were to do this on your calculator, you should be able to get this there. 17 over 65. So that's our answer. The final part of the question, you can give your answer in decimal as well, or you can say 0.262 to 3 significant figures. There we go. Take care.